Welcome viewers. In this video we will see the implementation of logic circuit using only NOR gate. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. Draw the logic circuit for the following function using only NOR gate. We need to implement the logic circuit using only NOR gate. The given function is f equal to a b c bar plus ab into c plus d. Right. Now we will simplify this expression and also we will convert into R form. That here the multiplication is available, a into b into c. But in order to implement the NOR gate, we need a plus b plus c bar like that. So that only we can implement with NOR gate. So we will simplify this expression and we also will convert into the R form. First we will multiply this AB inside, right. So this A, B, C bar plus AB into C become ABC, AB into D become ABD, right. Now we got this value. In order to bring it into R form, the complement is taken on both the side. F bar equal to ABC bar plus ABC plus ABD to the whole bar, right. So this can be, we can apply the De Morgan's theorem for the further simplification, right. So what is the De Morgan's theorem? A plus B the whole bar equal to A bar dot B bar. So based on that, we can take this is A, this is B and C. A plus B plus C the whole bar is nothing but A bar into B bar into C bar, right. So the plus is converted into product. Similarly, we can write this A B C the C bar the whole bar dot A B C the whole bar dot A B D the whole bar, right. So based on this Pythagoras theorem, based on the De Morgan's theorem, A B C the whole bar is written as A bar dot B bar dot C bar, right. So further we can apply the another De Morgan theorem. A B the whole bar equal to A bar plus B bar. Here the dot is converted into addition, right. So that A B C bar the whole bar is written as A bar plus B bar plus C double bar. Already one bar is available, right. Now the product is converted into addition. Similarly this one, A B C the whole bar is A bar plus B bar plus C bar. Similarly A B D bar D the whole bar is A bar plus B bar plus D bar, right, by applying this second De Morgan's theorem, right. So this C double bar is available, so it become only C. So that A bar plus B bar plus C. This one A bar plus B bar plus C bar. This one A bar plus B bar plus D bar. Now see this expression, the sum is available. So we can easily implement the R function, right. So there are three functions or three terms are available. This is the first term. A bar plus B bar plus C is the first term. A bar plus B bar plus C bar is the second term. A bar plus B bar D bar is the third term. Now we need to implement these three terms in the using the NOR gate. Now we'll go to the diagram, logical diagram. First we will see the inputs. So this is the input line A. In order to get the A bar, we are using one NOR gate. In that two inputs are short circuited. We are having common input. The common input is given for both the inputs. If the NOR gate with the common input means it will act as a NOT gate, right. The NOT gate function is obtained from NOR gate by short circuiting the two input and make a common input, so that this will act as a NOT gate. So we got A bar, right. A is given as a common input to the both the inputs, so we'll get A bar. Similarly this line is the B, the input line B. Here also one NOR gate is connected with common input, so we got B bar. This is the input line C. Here also C is taken from C and given to the NOR gate with common input. So here we got C bar. This is the input line D. Here also one more NOR gate is connected with common input. We got D bar. So we have the input line A, this one A bar, B, B bar, C, C bar, D and D bar. So A, B, C, D, 4 inputs, A bar, B bar, C bar, D bar, another 4 inputs are available, right. First we will implement A bar plus B bar plus C. right? So here we can, these three inputs are connected as A. This is A bar, this one B bar, and this one C, right? Three inputs are connected. What is the output of this NOR gate? These three inputs are added together, A bar plus B bar plus C, then to the whole bar. That is the nature of the OR gate, right? Now the first term is implemented. Now we'll go to the second term. The second term, it is connected with A bar, B bar, and C bar, right? So what is the output for this NOR gate? A bar plus B bar plus C bar, the whole bar. We'll got the whole bar, right? So the second term also now implemented. Now we have one more NOR gate to implement the third term. Third term is nothing but A bar, B bar, and D bar. These three terms are connected. What is the output for this? A bar plus B bar plus D bar, the whole bar, right? Because of NOR gate we got whole bar. Now these three terms are available. These three terms are connected to the one more NOR gate, right? So what will get? These three terms will be added, again one more complement we will get, that is called F dash, right? We have one more NOR gate is connected, so due to that NOR gate nature is, it will add these three function and one more complement will be available. So we got F dash, F bar. In order to get the F, we are using one more NOR gate with common input. So it will act as a NOT gate. So F, the input is F bar, means the output will be F. That's complemented. If it is F bar, mean it will be F, right? So finally we got our required output. We will verify this expression. This F dash, what we got by adding these three, how we got the desired output, we will verify with the expression. This is a diagram. Diagram wise we implemented, right? The three terms are implemented with the three NOR gate, and all three are added with another NOR gate, that is inverted by one more NOT gate or NOR gate by connecting the common input. So it acts as a NOT gate, right? Finally we got the desired output. Now we'll verify with the expression. We'll verify this, how we got from F dash and F. So output of the NOR gate is these three functions added together and will the complement, right? A bar plus B bar plus C, the first output of the first NOR gate. A bar plus B bar C bar is the output of the second NOR gate. A bar plus B bar plus D bar is the output of third NOR gate. These three are connected to one more NOR gate, so that it is added. These three functions are added and will give the one more complement. Now we can use the De Morgan's theorem to simplify further. So A plus B the whole bar equal to A bar dot B bar, right? So based on this term, A bar plus B bar plus C the whole bar is written as A double bar B double bar into C bar, right? So the addition is converted into multiplication. Similarly these additions are converted into multiplication. Here already one bar is there, so we got double bar, B also double bar, right? Similarly the same thing applied for A bar plus B bar plus C bar. So what we got? A double bar into B double bar into C double bar. Here plus is there, here multiplication, right? Already one bar is there, here we'll get one more bar, so we got double bar. The same formula applied for the third term also, right? So that is A double bar into B double bar into C double bar, right? So based on this Pythagoras De Morgan's theorem, A plus B the whole bar is written as A bar dot B bar, right? Based on that it is written. Now we'll go for the further simplification. This double bar become removed. A double bar is nothing but A. It will give the original value. So based on that it is A B C bar plus A B C plus A B D, right? So the F dash equal to, we got this, right? So here all double bar except this C, all double bars available. So that is removed here. Only the C bar we got, the C is got the bar. So this is nothing but F bar. So F bar available on both the side, complement available on both the side. That is, we used one more NOR gate with a NOT function. So by removing the complement on both side, what we got? F equal to AB C bar plus ABC plus ABD. So this is our required output. For further simplification, we take AB outside, so that C plus D. AB C bar plus AB into C plus D. So this is the given expression. For this only we implemented the circuit. We verified this output. We got this same output what is given in the problem as a output of the logic function. So we designed the logical circuit with NOR gate and we verified the expression also. In this problem, we implemented the given logical function using only the NOR gate. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Thank you for listening.